You're listening to EcoShock Radio for the world.
After you've written down some of your goals and decided to build a greenhouse, there is the planning stage. You can use my plans or make your own. In this first part of the course, there are not a lot of videos, as these steps take place out of sight. The later parts of the course are almost entirely videos shot on site at different times of the year over a 3-year period. You get hands-on looks at ways to build this geothermal greenhouse and my tips to operate it. Step 1. Make sure your ground is suitable for air geothermal at all. You should determine whether your location is going to work for geothermal. What is in the ground? Are there great big stones? Is it solid rock down below? How hard will the dig be? If there is a rock bed below, it's possible you just can't do geothermal. Blasting for this kind of project would be outrageously expensive, even if your municipality would let you do it in a crowded area, which I doubt. In my case, we had just excavated for our basement the year before, just a few yards away. Our home is built on sandy river till without even large boulders. It's cheap and an easy dig, but it requires extra space because the sides of the hole have to slant back 1 foot for each foot dug. So if you've got a hole that's 11 feet deep, you need 11 feet on either side for the slant of the fill, and that's for safety's sake, so it doesn't slide back in and kill somebody as they try to lay the pipes. Those are the safety regulations here in Canada anyway, especially for sandy soil. I suggest looking for a backhoe in your neighborhood to save on the transport charges and make a test hole around 9 feet deep. Put markers around it and tape so no one falls in and wait for a day or two. Did it fill up with water? So will your geothermal pipes. Perhaps that is only true in spring and the ground will dry up in other seasons. You can probably cope with that. I leave it to others to explore whether the heat in that water could be transferred to the greenhouse, but in general, my system of air geothermal will not work if the pipes consistently fill with water. The air can't move, and what do you pull out with the air is a bunch of sputtering water into the greenhouse and into your fan, and it makes your greenhouse humidity too high, which could lead to mold or fungus problems. Step 2, find the local bylaws and building codes to see if they will even allow this. This is absolutely key. You could waste a lot of money if your local municipality or county authority will not give you a permit. Perhaps you think you can build without a permit, but all your neighbors will notice a big excavator and dump trucks moving into your yard. Our village works manager cruised by to look at our operation the very same day. You may get a stop work order if you don't have a permit, or even get fined. Some country folk can build whatever they want, wherever they want. When I lived in the Canadian North, I built a house and a barn and a root cellar and a chicken house and an outhouse with no permits. And nobody cared what I did on our 200 acres. But anybody with a backyard needs to get a permit, I think. My journey can illustrate some of the hurdles and how I got past them. I drew up plans by hand, but they were accurate with all the measurements. It showed the greenhouse location on the lot with all the clearances to the lot lines. It showed my floor plans with notes on foundations, an elevation side and front view showing building techniques. I learned these drawings in high school. We had the height and all that, and there was a drawing of the below-ground pipe system, which was pretty simple. I filled out the building permit application form and attached my drawings. I heard nothing for 2 weeks. Then I got a letter from the village objecting to the geothermal pipes because there was a municipal well water nearby, and they thought my system might allow greenhouse chemicals to migrate into the village water supply. That's a fair concern. We all want clean water. But my air-to-ground system or ground-to-air system would not change local hydrology at all. A meeting with the local village administrator and the works manager was arranged. I explained the difference between air geothermal and water and showed them the system could never be changed over to water exchange by a later owner of the property due to the drain holes in the pipes buried below. The village withdrew their objection and it went forward to the building inspection office. Geothermal is new. You have to be prepared to teach authorities what you are doing and why, as well as any concerned neighbors. Please understand this about building inspectors. They are usually not experienced builders. Their job is to make sure everything is so tight to code that it covers their own butt. If there is no exact code for geothermal, they are lost. My building inspector had never seen geothermal, of course. They are trained to approve standard 2x4 construction or 2x6 in the walls. They do not know how to calculate or won't calculate the roof load onto a beam wall construction like mine. The only way out for the building inspector, make me pay other authorities to approve it. I got a letter stating I would need to hire a geotechnical engineer, and he or she would have to come to my property and assess the ground strength. Maybe that is because 3 feet of the building would be down in the ground, but we sure didn't need a geotechnical engineer for the big basement we dug just the year previous a few feet away. We just laid that out and dug it. A geotechnical engineer would have to travel at least 2 hours each way to get to our rural village. It looked to me like a bill around $5,000 Canadian. The inspector's letter also demanded drawings from an architect for what is essentially a shed in my backyard. Again, that would cost thousands of dollars before we even get a shovel in the ground. You don't have to do that with a Costco greenhouse or any of these cheap greenhouse kits. They go up, the snow crushes them, and there's no permits required. I studied the building code for our province in Canada and the local bylaws. In fact, there was an exemption for any plan requirements for an agricultural outbuilding. My greenhouse is an agricultural use, but I'm not on a farm. They would not accept that, and going to court would cost more thousands of dollars. Finally, I found the province of British Columbia knows that applying the full building code for every backyard shed is going way too far. So they make an exception for any building that is less than 10 square meters or 105 square feet. My original plans were for a greenhouse 9 feet wide and 18 feet long, which is big enough to require the building code. If I shrunk my greenhouse to 7 feet wide and 15 feet long, I would not need a building permit at all. That is smaller than I hoped, but given the alternatives, it was all I could afford to do, so I made it smaller. There would be no engineer or architect for me, there would be no inspection, and no requirement for plans. If you live in a big city, you may still have to hire an architect to provide plans for a building that is not in the standard box. Find out and be prepared to do what you need to do. With my little shed, I can do whatever I want. But I would have built it bigger if the outdated laws allowed it within a reasonable budget for just a homeowner. Perhaps this will improve as more geothermal greenhouses and other buildings go up and the authorities get used to them. Step 3, do you have enough space to put this and to build it? Let's talk about how much room you need to build a geothermal greenhouse. How big should the drain pipe area be? The truth is, despite my research and even phoning a couple of professors, there are no proven formulas for how much pipe can heat or cool a given amount of greenhouse space. I ran into a couple of formulas that were rule of thumb, and I could not find any proof, but I had to go with the best that I could respect. After a lot of research for a greenhouse 9 feet by 18 feet, I had decided on a bed 11 feet wide and 22 feet long. That allows me to use two 20-foot pipes and then have a foot on each end for the headers, the collector pipes. The pipes would then extend to a larger area than the greenhouse floor, and even more so when I shrunk the size of my greenhouse. Wanting to get as much air exchange as possible, I laid out two layers of pipes, one at 8 feet below ground level, and that's the deepest that I could reasonably get with an excavator, I felt, and a second one at 6 feet. We dug a hole 11 feet wide, 22 feet long, and 9 feet deep. I kept that size even when the new plans called for the smaller greenhouse. Geothermal is a weak energy, and the more area you have available for exchange, the better. Next question is where to put all that dirt. You really have to plan where the dirt dug out of your hole will go. There will be a lot of it. We managed to stack up quite a bit around the excavation, right up to our fences several feet high. I think we could have put more within the yard with more planning. Remember, though, you can't block access to the excavation because the gravel trucks have to get in there. Given the limited area in our yard and the slope requirements, we determined that 2 truckloads would have to leave the site permanently, taken to a friend's place who was looking for fill, and 3 truckloads would have to be placed either in the alley or in a friendly neighbor's empty yard area for a few hours and then brought back for backfill. Of course, we kept topsoil in a separate pile so we could restore it to the yard at the end of the project. As I said, the hole you dig must be larger than the space for the drain pipes to allow for safe sloping. Later, when you backfill the gravel and dirt, you also need to leave about 4 feet of ground outside of your foundation at your intended floor level. You will need that space to maneuver a wheelbarrow full of blocks or concrete. You need good access to both sides of a concrete wall when you're building it, and it's much easier to build from the outside. You don't want to wheel all your concrete over the doorway edge or something like that, or through a bunch of tools. If you check out YouTube videos of construction of geothermal greenhouses, you will be amazed at the amount of dirt that has to be piled up and stored for a while. Pretty well all of those greenhouses that I could find were built on acreage where there was lots of room to do that. Building within my backyard is pretty new. I had to plan my dirt, and so do you. And that's partly why I did this course, is so that people will see it can be done in a backyard. Step 4 is your time for scrounging materials before the dig. My greenhouse really started when a neighbor asked me to haul away 8 large plates of tempered glass. A previous owner had the glass mounted over a patio. It was thick, it was heavy, it was dirty, and a bit old. I thought it could make a great roof for a greenhouse, and here we go. So the roof glass came for free. You would be surprised at how much good glass is out there for free or very cheap. People get a little condensation on a double-paned window that's still okay, or they don't like the frame design, or they want bigger windows, and they take those old windows out. But it's hard to get rid of old windows. They can break on the way to the dump, for one thing. Chances are, if you put up a notice on Kijiji or Craigslist, you may find the glass you need free or very cheap. My 4-foot high, 6-foot long, double-paned windows, 5 of them, were found at a nearby neighbor's house. That person planned to make a greenhouse too, but then changed her mind. I paid $25 a piece for them. It was a real steal. Some of the windows opened and a couple even had screens. Glass may be the least expensive part of your project if you scrounge around and collect it ahead of time. I had my glass before I finalized my plans and my framing because window size will determine the framing. You also could be looking for things like a heat pump. I got mine used for $150. It was like a 4-way air conditioner that included a heat pump. The details follow, and I've got videos about that. At one point, I saw a small baby Fisher wood stove for just $125. I would have snapped it up. It was perfect. It was even airtight, but I had no place to store it at the time. That was several years ago. For this greenhouse, I ended up buying a camp stove or a tent heater for around $300, and it's worked very well. Look for a used electrical box maybe, perhaps 100 amps and some wiring. You could use a 30 amp box. You may see some lighting that's used. You will want at least two 4-foot long fluorescent workshop type lights. They should have like 4 bulbs each if possible. There may not be many used LED grow lights out there. They're just too new. Mine were less than $150 per 1,000 watt grow light from Amazon in Canada, so they're not too expensive. I did find used metal halide grow lights with reflective hoods and bought those dirt cheap, a few bucks. People are dumping the big bulb metal halides for LEDs, which use 20% of the electricity for the same brightness. I would save up for LEDs if you can, but the metal halides can help heat a winter greenhouse as well as light it at a fairly high cost in electricity. Maybe you can find a decent exhaust fan somewhere. It has to be weather tight and not indoor. Used lumber would be good if you can find that. Most contractors are recycling lumber these days. We have stores and local people who sell it. It's dry and it works well. I doubt if you will find used pipes for the underground, but it's worth looking around. Yes, metal is a better conductor for heat, and that would be ideal, but metal pipes, 4 inches in diameter, a couple 100 feet of them, well, that would cost a fortune these days. Even if you find some used, I warn you, the cost of all the metal fittings, the corner pieces, the cross pieces, will be a killer. The PVC pipe will last longer in the ground and does not rust, and enough air gets in those air holes that it works. For a budget greenhouse, assuming you aren't rich, PVC pipes work out best. It has to be drain pipe with holes in it. Most have holes in the bottom, which is good, so water and soil don't enter from the top. You lay it with the holes down. Look up French drains to find out more. Watch my videos and figure out what the materials are that you could find cheap before you build. Recycling used materials is easier on the pocketbook and the planet. Step 5. Where exactly will your greenhouse fit? You need to figure out where your new building goes on your lot. Probably 100 people are going to write me saying, I should have built my greenhouse on an east-west axis to get the most sun from the south. I know that is true, but other factors can impose. You may have a nearby building that would shade part of your greenhouse part of the day, or a tree if you build with that long side facing south. In my case, there was no way to get the pipes and gravel to go east-west without tearing apart a valuable garden that's been in place for over 50 years under various owners. I could not afford to excavate 2 separate holes, and in a small location like a backyard, the greenhouse has to go over the gravel bed and pipes. That works out best anyway. So my greenhouse, yes, it has the longer side facing west. It still works just beautifully. If you are in a northern location, please consider where the snow and ice from the roof will go. Some of it will slide off a glass roof with a warm building underneath it. That cannot be allowed to slide onto things like your neighbor's yard, your car, or a key walkway you will need all winter. Think about it. Where will all the rainwater go? Into your basement steps? Rainwater should be collected if possible, and my design uses eaves and soffits, that's the wood along the edges, which is built to easily accommodate eaves troughs. I haven't installed them yet, but I do have a barrel to collect that water. If you are in a rainy area, the final landscaping will have to build in a slope or channel to take water away from the greenhouse or any other buildings. Plan for extreme rainfall events of several inches of rain in 12 hours. That's happening more and more in the future. Where will it go? Along those lines, you will probably want a water line and electric power to your greenhouse. I had a long, thin trench dug 4 feet deep, so below the frost line, from the house to the greenhouse, and put in both water and power lines there. There were separate plastic pipes down there, a PVC 2-inch with no holes in it. Map that out so you don't have to go too far. If things don't work out, you can carry water in buckets or use a hose during the summer season, but not in the winter. Maybe you can string a wire in the air from your power source, say your house, to your greenhouse. It would take a lot of solar panels to provide power for grow lights needed in northern winters. I doubt you can do that, but you could run fluorescent lights from solar, and they work for smaller plants and seedlings. At least fluorescence will keep them alive, but maybe won't make them grow at all. The door to your greenhouse should be closest to your house door. Don't make yourself walk around buildings to get there. You want to go often. Figure out pathways that are the most direct and instinctive and comfortable. Did you leave room for an excavator to perch and dig out the hole? If you have a gate, can an excavator or dump truck get into your greenhouse site? Can a dump truck back right up to the excavation site? To make a real geothermal greenhouse, this has to happen, unless you have a few years or 20 people to dig mountains of soil by hand. Consult with a heavy equipment operator and find out what room they need to enter and work. Consider other zoning regulations. For example, in my village, no building can be within 5 feet of a neighbor's fence. A garage can be right on the back alley, but a guest cabin or other building cannot, requiring a setback, so find out what the rules are going to be for your greenhouse. In the final step, you prepare for the big dig. You need to explore all these things before putting pegs in the ground to show the greenhouse location. Keep in mind, those pegs will be dug up and run over. I measured out from the end of the greenhouse location and tied red tape to the fence to mark all the points. Only markings at the perimeter, where you can measure back from those, will survive. But you can use pegs or spray painters to show the excavator where the main hole and its dimensions should be. Well before the day of the dig, you should have all your PVC pipes and connections on your site. I assembled mine into large sections in my backyard first. Make sure it fits with all the corner pieces and connections. I describe how to do this in later videos. The idea is to use as little time as possible to set the pipes up in the gravel while the excavator is waiting hour by expensive hour. Test it all out and have segments of the pipes ready to go in quick. Don't glue the pipe connections together. Good quality PVC pipe will need to be tapped into corner pieces and so on with a rubber hammer, and should hold together more or less while you get them in place. Glue prevents you from making adjustments or fixing mistakes. The corners may need to rotate a bit, for example, because the gravel is not quite level. If you glue it, you can't do that. Arrange for a friend with a shovel to show up on the day. There will need to be a little handwork, and many hands make it faster, while time counts for the excavator. Have any fences or gates that need to be removed down the night before. Ideally, the dump truck should remain on the site or at least be close by on call. Several loads will have to go somewhere, and my excavator brought his own dump truck with his son driving. He was supportive of this project. Explain what it is so people can help do it right. I arranged a place for extra fill to go beforehand. Truckers charge by the mile and quite a bit, so the closer dump site you can find, the better. A surprising number of people, maybe even your neighbors, have a low spot they wish was filled, especially if it's free, or your municipality may wish to have a little bit of free fill. You may even be able to sell a couple of loads to offset your costs. Talk it over with your excavator to estimate how much should be hauled off and how much to save on site for backfill. They know these things. In my experience, backfill requires more soil than you think. It's better to keep a bit too much on your site if you have the room, providing the soil can be stored in a place where it can be reached for later removal if required. If this all sounds like too much, most excavating companies will come out in advance, talk it over with you, and tell you what is needed. Some will just do it all, except laying the pipes, and might even help lay the pipes. The job is not too hard for them. It's not that much different than putting in a septic tank and weeping tile. You may want to get 2 quotes. I knew my excavating company beforehand by its good reputation. If you don't know anybody, beware. Get all costs in a written estimate before the dig to avoid really nasty surprises. One person I know paid twice the going rate for her basement dig. Buyer beware. It is common in this area for heavy equipment to arrive even a couple of days later than agreed. The excavator may get stuck on the job, or maybe their best customer just called at the last minute. Be prepared for this possibility. Don't freak out. My bill, which was based on an hourly rate for equipment and a fixed rate per truck of drainage gravel, came to $4,100 Canadian. That is about $3,100 US or 2,800 euros. That was by far my biggest cost. The rest I was able to build or do myself. 3 years later, I still think it was money well spent. I'm Alex Smith, host of Radio EcoShock, as broadcast on 100 radio stations in the United States, Canada, the UK, and Australia. Thank you for listening, and thank you for caring about our world.
You're listening to EcoShock Radio for the world.